So guys, this concept development here, what we have to do is pretty much figure out and sim through net forces. So we have a couple different forces acting on it. We have these free body diagrams to kind of give us a help, give us a hand here. Weight is our force going downward. Normal force is going to be our lowercase n here going upward. If this thing is at rest, things need to be balanced, okay? So you can figure that out. So that's if something's not moving, net force has to be 0. If something's moving at a constant speed in a straight line or a constant velocity, the net force has to be 0. So that will help you answer a few of these. Number 2, you have a pull force exerted on the crate. It's not enough to move it, which means if it's not moving, things need to balance out, right? So the normal force and the weight are already balanced out, like we look at number 1. So what does that mean about pull force and friction force? They're going to have to wind up balancing out. So that means they would have to be equal to each other. Number 3, P is now increased so that the crate begins to move with a constant velocity across the floor. So again, constant velocity means constant speed straight line. So that means everything has to be balanced. So even though it's now moving, the pull force and friction are, again, equal, which means constant velocity, the acceleration is 0. Net force has to be 0. 4, pull force is increased and is now greater than the frictional force. So now it has a net force that's not 0. All right, it's greater than 0. And if the net force is acting to the right, the acceleration is going to the right. If the pull force is 150, the crate doesn't move, what would the friction force have to be? It would have to be 150 newtons if it's not moving. Now, if you pull 250 newtons, the crate doesn't move. What is the magnitude of friction? Yeah, now it's 200. The force of sliding friction is 250. What is the force necessary to keep the crate sliding at a constant velocity? That would have to be 250 because a constant velocity means a net force of 0. Okay, the mass of the crate is 50 kilograms. The sliding friction here is 250. What is the acceleration of the crate at these points? So acceleration is F net over m. Okay, if this friction force, so basically you're looking at it like this. Your pull force is going to switch up to be 250, 300, 500. The friction force in each of those is going to be 250 newtons. So if the first one, 250 minus 250 is 0, 0 divided by 50. You'd have 0 meters per second here, meters per second squared. The next one, 300 on this side as the pull force, minus 250 would be 50. That would be your F net divided by the mass, 50 divided by 50. Then you have 500 over here. 500 to the right, minus 250 would give us 250. 250 divided by 50 should be what? 5, I believe. Okay, on the next set, on these sides, on this side, so over here on your doc, all right, I put it like A, find the acceleration at points A, B, C, D, blah, blah, blah. You're doing the weight of the skydiver minus the air resistance. So in this case, you have 1,000 minus 0 divided by the dude's mass, which was 100 kilograms in each of them. So 1,000 divided by 100, what is that? 10 meters per second squared. And you're basically going to just show that for all of those. Okay, so it's very, very simple. You're just kind of repeating the process. Now it would be 1,000 minus 400. Eventually, you will get a negative. That's okay. Then you have to figure out where his speed is the least. All right, when is his speed, where his speed is the least, it would be at the very, very top because he's just stepping out of the helicopter. And you'll figure out, is his acceleration the least or is it the most? You'll be able to figure that out with your numbers. I'll tell you right now, it's going to be most of that. Okay, in which one of these does he experience a downward acceleration? All right, the downward accelerations are going to be the one where he's falling. If it's a negative acceleration in this case, that's when the chute gets pulled, okay? And it will be like considered a negative, but the downwards acceleration is where he's going to be moving downward. Terminal velocity means velocity is the same. All right, so figure out where his terminal velocity would be the best or the highest. All right. See you guys. You too, guys. Goodbye.